This is a 2-day lesson. Day 1, we're using the graphing calculators in class, and then day 2 is a work day to work on the assignment with graphing calculators. You will learn how to do all of the same things without a graphing calculator though, so it isn't required. Our essential question is, what effects do transformations have on quadratic equations? A transformation, you learned in pre-algebra about transformations, and there are a variety of different types of transformations. All 3 of these are types of transformations. A translation is also known as a slide. It's when a figure stays the exact same size and shape, but slides to a different location on a coordinate plane. A dilation is a size change, where something gets bigger or smaller. And a reflection is a flip. And with a reflection, you have a mirror image. So you might be reflecting over the x-axis or the y-axis, but a reflection involves flipping the figure over. So it's still the same size and shape, it's just in a different direction. Our first question is, graph this quadratic on a graphing calculator. Y equals x squared. This quadratic is called the parent function. Describe its characteristics. After graphing this function on a graphing calculator, what we found out is that these points are on the parent function graph. 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. This quadratic is called the parent function because it's the most basic parabola. It has an axis of symmetry that is the y-axis. So the axis of symmetry is x equals 0. The vertex is 0, 0. Now, what we are going to be exploring is what happens when we make some changes to the equation y equals x squared, and what those changes to the equation do to the graph of the quadratic. So next we're going to be graphing 3 quadratics on our graphing calculator at the same time so that we can compare quadratic number 2 and number 3 to our parent function. So number 1 is going to be the parent function again. So I'll sketch that first, and then the other 2 we are going to compare to the parent function. So by looking at these on your graphing calculator, you'll be able to tell what effect the +3 has on your quadratic. What happens is it shifts the parabola up 3. So all of the points slide up 3, which makes this a translation. So number 2 is my blue, and that is a translation up 3. So the parabola doesn't change in size or shape, it simply slides up 3. My next quadratic, the effect of the -4 then, is to slide the parabola down 4. So each of these points slides down 4. Again, the quadratic does not change size and shape. It simply slides to a different location on our coordinate plane. So the effect of adding or subtracting a number onto x squared is a translation. If you add a number to the x squared, it is going to be a translation where you're sliding up. And if you subtract, it is a translation where you are sliding down. Now, we'd like you to look at these 3 functions and, without graphing them, be able to describe what's happening. So, what's happening with number 1? If there's a -7 after the x squared, it's a translation, and it is sliding down 7. Number 2 has a -5 being added to x squared. Now remember that that would be the same as x squared minus 5. So the translation on number 2 is again moving down. So it's sliding down 5. And then for number 3, adding 3 takes our translation and slides up 3. All right, now we're back to the graphing calculators. We are comparing our parent function to 2 more equations. So I'm going to start with my parent function on my graph. And then we are going to graph y equals 3x squared. What you notice on your graphing calculator is that it still has a vertex at 0, 0. But when you put in 1, if you look at the table function on your graphing calculator, you'll see that you get 3. Think about it. 1 squared is 1 times 3 is 3. So this is not the same size and shape, which makes it a dilation. So number 1, because the size is changing, is a dilation, and we call this stretched vertically because it has gotten thinner. So it is called stretched vertically. Think about if you stretch something vertically up and down, it's going to get thinner. This should be a number 2. Okay, and number 3. Y equals 1/2 x squared. Please remember, if you're putting this in your graphing calculator, you really need parentheses around the 1/2 and use the division sign on the fraction. Otherwise, you could convert it to a decimal, 0.5 or 0.5. Okay, again, the vertex is at 0, 0. You see that in your graphing calculator. But when we put in 1, what happens is we get 1/2. We get 1/2. And when we put in 2, 2 squared is 4, half of 4 is 2. So we get 2, which means that this parabola is wider than the other two. Wider than the other two. So number 3 over here is a dilation. Number 3 is a dilation, but it is not being stretched vertically anymore. It is what's called compressed. Compressed vertically. Because compressing something, if you press down on it, it is going to get wider. So compressed vertically. Okay, now without a calculator, without a graphing calculator, number 1, what is happening if there is a 2 in front of our x squared? The 2 results in a dilation, and because that value was bigger than 1, that coefficient was bigger than 1, it is going to be stretched. So stretched vertically. Anytime that coefficient is greater than 1, it is stretched. Number 2. Now we have a coefficient of 5. So again, it's a dilation and it's stretched vertically. Stretched vertically. It's actually stretched even more than the first one. The higher the coefficient number is, the more stretched it is. And number 3, with a fraction of 1/4, because that is less than 1, you'll see that that is a dilation, but it is compressed vertically. Okay, our last type of transformation for today. Start with the parent function again. So our parent function, we are only comparing one new graph to it, and that is y equals negative x squared. What happens when you graph this on your graphing calculator? So you see that it is a reflection. The negative sign flips your quadratic so that your parabola is upside down. That is the effect that we see with this negative sign next to the x squared. So if the coefficient is negative, it's going to flip your parabola upside down. So that is called a reflection over the x-axis, because the x-axis is our horizontal axis. Okay, now putting together all of these transformations sometimes gets kind of tricky because we have more than one thing happening to our equations. So on number 1, the effect of the -4 is a translation. So it's a translation down 4. And then the effect of the 5 is a dilation, and it is stretched vertically. Stretched vertically. So 2 things are happening to this quadratic. On number 2, we have 2 things again. The +2 means it's a translation, and it's going up 2. And the 1/2 means it's a dilation, but because it is less than 1, it's compressed vertically. Number 3, the +1 gives us a translation, up 1. And the -3, we're going to have to think about this 2 ways. The negative sign makes it a reflection over the x-axis, and the 3 makes it a dilation stretched vertically. So with that coefficient, it's pretty tricky. You have to separate out the negative sign from the number. So on our last one, we have 3 things again. So it's going to be a translation down 7. It's also a reflection because of the negative sign. And that reflection is over the x-axis. And then last, it's a dilation, but this time it is not stretched, it is compressed vertically because that fraction is less than 1. Be careful with your fractions, because if it's a fraction but it represents a number larger than 1, it's stretched vertically. If it's a fraction that represents a number that is less than 1, remember we're ignoring the negative sign, then it's going to be compressed vertically. Okay, now you should be able to write your summary answering the essential question for today. And here are your homework problems that we worked on day 2.